Here we so welcome, happy free prep hour evening. I've got March 25th, 2024, a beautiful day here in Durham, North Carolina, where I live. My name is Whitney, and I am a GMAT, GRE, and Executive Assessment instructor here at Manhattan Prep. And I'm excited about today's session. I'm going to work on a topic today that shows up both in the quant section as well as the DI data insights section. It is a concept known as overlapping sets. So we're going to be trying quite a few practice problems along the way. So let's do it without any further ado. Let's get going. Oh, I got a picture showing up in the way. Here we go. So this free prep hour, right? Again, my name is Whitney. If come hang out with us anytime. The plan for tonight is overlapping sets, and we find overlapping sets in both the quant and the data insight section. And not just on the old quant question type of data sufficiency, but also we'll see an example tonight of overlapping sets as it shows up in even more types of questions in the data insight section. But what I'd like for us to really focus on is I want you to be able to do two things by the end of tonight's class. I'd like for you to be able to spot what I'm going to call overlapping sets. And I'd like for you to be able to apply a double set matrix to the majority of those problems. We will look at some variations in overlapping sets before we go, but these are the two big things I want you to be able to do is spot them. So how do I recognize that I can use an overlapping sets concept or construct? And then once I'm there, how will I then apply a double set matrix? Yeah. So let's just jump in. We'll try a problem. I want to kind of put it on the screen, and it's in the form I think that might be a little easier for folks to recognize in terms of overlapping sets. But I want you to give this problem a try. I'll set a timer for us. I'll cut us off in like the 2 minute ish mark, but do give this one a go and send me your answer in the chat window if you're here live. Love to see what you get. All right. Okay. I love it. I love it. I've got answers in from everybody that's in the room. Fantastic. Or starting to get answers in. Missing just a couple. Mhm. Okay. So, given this problem, I want you to take a moment and sort of type up to me in the chat window, where do you think this name overlapping sets comes from. What does that mean, overlapping sets? And how might you often see an overlapping set? Overlapping set. Like, yeah, so I love this. Thank you. Yes, we've got this concept of overlapping sets that comes from the visual that is often used of a Venn diagram or overlapping circles, right? And so what we might be used to when seeing a problem like this, we've got, set A with set B, and they overlap in some way, right? And so if we were to sort of sketch that out, our set A, set B's that would overlap, right? I might say that, okay, over here in set A, right, over here I've got set B, and I know that there are 30 integers. I'm not entirely sure where to put that yet. I know that A has 15 and B has 22, and 8 would be where they cross over. So I could then kind of figure out how many are in the moon shape on either side, because this 15 and A are for all of A. So if there are 8 in the both, that would put 7 in, this category of like only A, like A but not in B. And 8 from 22, I take 2 down, then another 6 down, so that's 14 are over here. So that would be 14 that are in B but not A, so only B. And if I were to add these numbers up, right, or conversely, I could have added these two and sort of subtracted that overlap. But if I were to add these up, 7 and 8 is the 15, plus these 14 here takes us to 29. But I'm told that I have 30 integers. And so I often need to build a box outside that would say, okay, there's like 1 in my neither. Right? Okay, so overlapping sets gets its name from the kind of like concept of overlapping Venn diagram style circles. However, this visual representation, although powerful, is quite limited, and it can become quite challenging when we start to think about situations where it becomes a little bit trickier to put information. So I want to give you an example, right, of a problem that I don't need you to solve right away, but I do want you to try. Um, it's a problem that is a perfect example of why a Venn diagram is tricky. Okay, so we're going to spend about a minute and a half on this problem, so not enough time to fully do it. But what I'd like for you to try and do is ask yourself, how would I set this up in a Venn diagram? Right, like how would that fit in this, like, okay, set A, set B, and the overlap? Yeah, so let's give this one a go. I'm not saying that it's not overlapping sets, but I would like to see, like, how would I Venn this? Right? What would that Venn look like here? And fear not, we'll spend some time actually figuring out how to solve this in a little bit. Okay, so a couple of questions for this one, but I'll start with what if you just trust me and I tell you that this is in fact an overlapping sets question? Okay. Um, how in the world would you get this into a Venn? So if anybody's got some ideas, I want you to try and type it in the chat window. Or if you were stuck and you were like, I don't know how I would put this in a Venn diagram, say that. So I want to hear from y'all in the chat window. What was your experience trying to put this question into a Venn diagram? How did that go? Okay. I got a couple of good guesses. Also highlighting the challenge of trying to do this. I've got a couple of people saying they weren't sure. Hmm. Okay, so I have somebody saying that they thought it was like 4 circles. Okay. So this is actually one of the issues with the way the GMAT writes questions, right? On our previous example, we had a situation where it was like pretty clear. We had set A, right? You're either in set A or you're not. You're either in set B or you're not. So we have two categorizations here. There's like set A, in or out, and then there's set B, in or out. So it's in some ways almost this like on off switch of two different qualities. There's a set A quality, and it's either set on or set off, right? It's either you're in it or you're not. And then there's this other quality, set B, and you're either in it or you're not, right? So we've got these like two almost, I think of them as light switches. That they could both be on at the same time, meaning you're in them both. They could be off at the same time, meaning you're in neither. Or they could be on one at a time, meaning you're like only in set A but not B, or only in B but not A. And so we create this like selection of options. In fact, it's 4 different options in some way, as we think of these on-off combos, right? Where these two in-out groups commingle, where they cross. Well, if we look at this set, if we were to think of it as just the words that were given, we might be tempted to be like, okay, you're either a hardcover or you're not. You're a paperback or you're not. You're a fiction book or you're not. But oh wait, but you're a non-fiction. Okay, wait a minute. So the circles are a little trickier because unlike the set A in or out, set B in or out, there's almost a, like cover option where it's like hardcover or paperback. That's the slight switch, right? It might be a hardcover cover or a paperback cover. The other option is the style, right? The writing style, the genre. Maybe I'll put it that way. And the genre would be fiction or non. So these are our two on-off switches. So there'd be a circle for my cover and a circle for my genre. Okay. And I would have to, as some of you mentioned, choose one of my covers to be the sort of listed group. So maybe I'd have to call this group, somebody mentioned paperback. So maybe I call this paperback. And then this would be my genre one. Maybe I'll call this fiction. So anything that goes here would be paperback and fiction. Anything out here would be fiction, not paperback. So in this story, I have to translate not paperback. If I'm going to use this kind of model, I have to translate not paperback to hardcover. So this moon would be hardcover fiction. This moon on the left would be paper fiction, or excuse me, paper nonfiction. And then if I had a box out here, this would be not paper nonfiction or hardcover nonfiction, which I'll be honest, gets kind of messy in a Venn diagram. In fact, it gets very, very messy in a Venn diagram. So I want to introduce a different model, which is the double set matrix. It is an alternative to our Venn diagram that I find to be just immensely powerful. Okay, so let's go back to our original question. If I remind myself of a Venn diagram where I've got, group A and group B, and then I've got the, box around it. So this is like my group A, this is my group B, this guy in the middle, this is both. This is like only A, only B, and this is neither A nor B. I want to think of a way that I can more easily represent not just these four sections, right? I've got this kind of both section, this only A section, this only B section, and then this neither of them section. So not only a way that I can represent those, but notice how when we solved this before, I just had to kind of stick A equals 15 out here. And remember that it applies to the whole circle. And this B equals 22 applies to this whole circle. I'd love for there to be a way to incorporate subtotals. Right? So it's like where can I put this 22 and this 15? And so it turns out there's a really nice kind of stolen from Excel trick. And the trick is to start with a 3x3. So the first thing is if I start to realize I'm in one of these like, oh, I've got two qualities, they turn on and off, and they sort of hybrid with each other, I start by building a 3x3 grid. Now, for those of you that are like, oh, but I learned a formula for these, I'm going to tell you right now, applying a formula to these on the test is a pain because they will often write the questions in a way that makes setting up, right, that kind of whole equation a pain, like difficult. Partly because it depends on how they give you the information as to how you should be setting up an equation. Right. So I don't ever use the equations for any overlapping set problems, nor do I use a Venn diagram. I 100% of the time use a double set matrix. So a double set matrix is going to be a matrix, like a little graph. So we'll do a 3x3 table. It's a little Excel chart. Okay. And then just so that we can do this together, I'll number my little squares. Okay. Now, to set up one of these, what we'll look at is we'll see that these four squares in here, these are the sort of correlate to the four spaces on our Venn. Okay, and then we'll have this row along the edge where we can deal with things like subtotals and the total. So we have places to put every number we might be given. So unlike a Venn where we're not always given a home to put all these numbers, we have a home for everything in this double set matrix. Okay, so the easiest, safest way to set up this matrix is to say to yourself, right, once you've drawn your 3x3, to say to yourself, put your finger in the top left corner, top left box, and say to yourself, both. So what you're trying to do with that box is just like a good table. You need to label the columns and the rows so we know what the heck goes in them. And so we're going to put our finger on both, and we're going to label that box whatever two tags something or someone can be both of. Okay, so in this scenario, someone can be both in A or a number can be both in A and in B. So that's step one. We label our both. Okay, so, well, I guess that's step two, technically. Step one, right, step 0 is recognize overlapping. And we'll see several examples. We're going to start moving through them a little bit more quickly. Right, so we're going to recognize overlapping as like two qualities that turn on and off. Then we're going to set up a 3x3, matrix. Step 2, we will ID the top left corner, both labels. So step 1, we ID that top left and we say what they're going to be. The order doesn't matter. You could have had A on the left and B on the right, or B at the top. All that's fine. Then you will write their opposite next to them. So in this story, what's the opposite of A? So if you're not A in this story, you are not A. If you're not B in this story, you're not B. And then finally, we finish up with totals. So the final column and the bottom row will always be totals. And we'll be using these rows as just like in Excel, like imagine you had a sum in each one of these. So box 3 would be the sum of boxes 1 and 2. So if we think about this, box 3 would be everyone that's in set B that could then be subdivided into whether they are in A or not. So the totals would be like the full circles in our Venn diagram. But what's cool is that we also get a total for the left out group. So in this diagram, not A would be all of this outside stuff as well as this moon for B. So if they told me the number of people not in A, I don't really have a home for that. The only home I have is for in A, kind of. Okay. So let's take this and let's set up this problem and see how it plays out. So if I've set all my pieces up, I want, my set A, right, where I've got 15. Oh, and I should point out that this overlap, this both would sit right here. Yeah. Group 2 would be the people who are in A but not in B. A but not in B. Group 3 would be the people who are in B but not in A. So that's B but not in A. And then this final group out here, the number 4 people would be the people who are left out of both. That would go right there. Now, if these were real numbers, 1, 2, and 3, we could then add them up. This would imply that there are 4 people in set B, there are 7 people not in set A, there are 3 integers in set A, and we can continue. Okay. Okay, so we finished with our little totals. And now we're going to fill in our box. So when we go to fill in this box, let me get rid of this guy. Here we go. Okay, so when we go to fill in our actual box, I have a home for every piece of information that they give me. So in this story, I've got 30 total integers. So that's my total, that's my everybody. So I have 30. And 15 of them are in set A. So I have to consider, do I know anything about their inclusion in set B? And for this grouping, no, I don't. I just know that they're in set A. So 15 in set A, which would imply that there are 15 not in set A because they add together. I've got the same information for B. 22 are in set B, meaning total, which leaves 8 people, or 8 integers, I should say, not in set B. They tell me that there are 8 in both. And so from there, I can fill out every other category. If there are 8 in both, that would imply 7 to get up to my 15. If there are 8 on this side, that would imply 14 because 8 plus 14 is 22. And this difference here in either direction would be 1. The question is asking for neither, which puts me right here. And my correct answer is A. All right, so Scale of 1 to 5, 5 being the most comfortable, 1 being the least. How do you feel about the table? I've got a 5. And type it to me in the chat window. It's all private, so you're welcome to send it. Nobody can see it but you. Okay. I've got some 3s and 4s. I like it. We're going to try it again. Fear not. Yeah. So let's do this crazy, complicated paperback business, right? So we've got 2 categorizations. We've got a cover and we've got a genre. And you don't have to actually get any of this on your paper, but it is how we start to recognize the usefulness of a double set Venn, right? So this double set matrix, excuse me. So I'm going to draw out my square, and I'm going to separate it into a 3x3. And then do me a favor. I want everybody to type to me in the chat window, what is something that we can be both of? So that's where we start. We always start with the both corner. And this will lead you to be able to do the kind of check to make sure you've got everything set up right. How do we do a both? Okay, I've got a couple of guesses. Any others? Yeah, I love it. Okay, so I had several of you all say paperback plus fiction. So, right, we've got 40% of the paperback books are fiction. So it would appear that we can do, a hardcover plus fiction or paperback plus fiction. It doesn't matter. So I'm going to go with the one that everybody gave me, which was paperback and fiction. That's my both. Now I'm going to write what the logical opposite is. So what's the opposite of paperback? Well, in this story, the opposite would be hardcover. The opposite of fiction would be not fiction. And then I'm going to throw my totals in. Now we have an extra trick that we can use on this question, and it's a trick that we can use on overlapping sets questions a lot. Does anybody know what it is? There's a big meta strategy. I made a lesson on this a few months ago, but what do we do if a question doesn't have any real values? Notice everything is like percentages, relative amount. Any ideas what we can do? Beautiful. We can apply smart numbers. We can assign a value, right? And so if this isn't something you've used before, you should absolutely check out the, on our YouTube channel. There's a full lesson on all the ways we can use smart numbers. But because there are no real numbers given, everything is in percentages. I'm going to pick a smart number. I'm going to pick 100 because that's easy to use with percents. And I'm going to make, in my story, that there are 100 books on a bookshelf. Okay, so let me clear out my both. The first thing they tell me is 60% of the books that are paperback and half of the hardcover books are fiction. Whew. Okay. So 60% of the books are paperback and half of the hardcover books are fiction. Okay. So the key when it's percentages, we need to be really careful what we're taking a percent of. So this says 60% of the books. Okay, so that's 60% of these. 60% of the books are, that's their verb, paperback. So paperback represents 60 out of 100 books, which means hardcover would be 40. Next, half of the hardcover books are fiction. Okay, if half of these 40 are fiction, that means 20 are fiction and 20 are nonfiction. If 40% of the paperback, okay, well, I have 60 paperback. To find 40%, I can find 10%, which is move the decimal place once, 6. 6 times 4, so 10% is 6, 40% would be 24. 24 of the paperbacks are also fiction, which leaves 44 fiction, and then 56, right? And I could calculate around. And then the last one here would be 36. And it says, what percent of the books are nonfiction? So I want total of my nonfiction. And so it's 56 out of 100 or 56%. So even when our on-off groupings have kind of creative labels of their own, this double set matrix is really, really powerful. So what I'd like to do is try a couple of problems that are a little less complicated than that one, a little bit. But just to start to get this table down, okay? Start to get the little table down. All right, so let's give this one a go. We'll take about 2 minutes, and then we'll talk about this question together. All right. I've got a couple of answers in. How are we feeling? Confidence level on this one, 5 being the highest, 1 being the lowest. How do y'all feel? And for those of you still working, have some answer. I'd like to know too. Okay. Yeah, that's why we're going to do a couple more together. So, what are the signals for overlapping set? What are my groups? How do I know that I've got an overlapping set problem? What do y'all think? How do I know? Yeah, we've got 2 criteria. I love that, right? So we've got what's its color? Is it red or not red? And then what's happening with its heated seats? Does it have heated seats or does it not? Cool. So that would be my overlap, like the color and the seat. So we'll do a 3 by 3. And then I'll pick whatever could be both. So cars could be both red and have a heated seat. So I'm going to say red and heated. And then the opposite of red would be not red and a total. And the opposite of heated would be not heated and the total. And there are no real values given. Everything's percents. So with percents, I'm going to pick 100. And then I'll begin. If 10% of all cars, so 10% of all my cars are red and have heated seats, so 10. And then it says, this one's weirder, 75% of the cars without heated seats, but I don't know how many cars there are without heated seats. So I'm going to hold off on that one for a second. If 40% of all of the cars are red, okay, so 40% of all the cars are red, that puts 60 here. What percent of the cars have heated seats? So I'm looking for this one. Well, I have one more. This is 30 right here. And it says 75% of the cars without heated seats. So this would be my cars without heated seats. And I don't know what this number is. So I'm going to put a little X here for a second. So this number, 30, is 75% of this number. So 30 is 3/4 of this number. Oh, okay. So if 30, we can do this a few different ways, is 3/4 of a number, you might automatically see that 30 is 3/4, right, of 40. You might see that proportion. Or you could solve the equation, right? Which means that this missing piece, right, X is 40. This middle number here is 10. This is 50. And then I could go from either direction and get that heated seats represent 60%, 60 out of 100 of all of our cars. Okay. Let's try one more of the somewhat more straightforward ones, and then we'll try 2 variations. So let's give this one a go. All right. If you haven't yet, go ahead and be sending me at least the best guess. I've got answers from quite a few of you, though. So my qualities are new or used, for lease and not for lease. Okay, I can set those up. Get my little 3x3, doesn't have to be fancy. And I look for what could be both. And it sounds like I could be used and not for lease. I'm going to go used and for lease. The opposite of used is new and its total. I've got stuff for lease or not for lease and its total. I know that there are 30 cars on the lot. 14 were new, which would mean that 16 were used. 18 were for lease, which means that 12 were not. And 3 were used and not for lease, which means 13 were both used and for lease. 5 were new and for lease. And since that's the one I want, I can stop there. And that gives me my correct answer. Nice. I got a bunch of answers on that one. Beautiful. All right. Well, so let's look then at how this can show up in some weirder spaces like data sufficiency. Let's give this one a go. So we'll see the two ways, two examples of how this shows up in data insights, one of which is the data sufficiency question type, where the answer choices remain unchanged. All right, so start to get me at least a guess, right? If you're not quite sure, I'll take a guess. Okay, I love it. I love it. Very nice. Okay, lots of good guesses, right? Point is trying to get a guess. All right, so we've got a story problem in data sufficiency. So one thing I will note about data sufficiency is that I often kind of read over everything once just to kind of figure out what the story is before going back and actually approaching data sufficiency. Where my job in data sufficiency, as the answer choices make pretty clear, is to evaluate those statements as independent facts. But at first, I'm just going to take everything to sort of see what kind of question I'm dealing with. And we have classes that require neither a final exam nor a final presentation, but then the statements talk about requiring one but not the other, or both of them. And so this really does feel like overlapping sets. If that's what I think that I'm going to apply to this problem, then what I'll do is I will build an overlapping set for one of my statements. So whichever statement, doesn't matter, I'll just write it out for one of them, with only the upfront or general knowledge. So I know that I have classes with a final exam and some classes that have a final presentation and some that have neither. And then there'll be some totals. The other thing I know is that there are 60 classes total. Once I have a double set matrix from generic information that applies to both statements, I will quickly copy it down so that I can then use it for both. And so that I don't accidentally, I am not a fan of using the same table for both statements. I have certainly seen some people use the same table and like draw a diagonal and write the information from the two statements in different places, but I find that that's a bit dangerous. So I'll start with statement, either one, they look about the same to me. So I'll start, and I should note the thing I'm looking for, which is classes that require neither. Right. So what I'm looking for is this middle box. You might put a circle around it, like kind of circle it. So of the 60 classes offered, 20 required a final presentation, but not a final exam. So 20. No way for me to get here. I only have these two pieces of data. So can't do it. I'll move to, so this would be not sufficient. So if our statement one is not sufficient, what answer choices can I eliminate? If our statement one is not sufficient, what answer choices can I eliminate? So it's definitely not that statement one alone is sufficient. And it's not that each statement alone is sufficient. So I'll kill off A and D. So now let me try statement two. In statement two, of the 60 classes offered, 30 required both a final exam and a final presentation. On its own, I still can't get into this center piece, not sufficient. Right? So if statement two is not sufficient, what do I eliminate? Very nice, y'all. Keep it coming. Yep, I eliminate B. So now I'm down between C and E. So C, just for those of you that haven't seen this in a while, C is where I put the two statements together, finally. And so at this point, I don't really care which of my two tables I'll use because I'm not going back. I will just kind of make a note to myself over here that this has become 1 plus 2. I'll bring the 30 over here, which gets me to 50 and to 10. But I cannot get to this square without more information about the exam. And so I still can't get an answer with 1 plus 2 together. Therefore, the correct answer is E. Not enough information. Not enough information. So they may give us, and actually it's somewhat common to see overlapping sets in a data sufficiency where now we have to manage two tables. Still, much easier to keep your information straight if you have them nice, neat, and separately organized. So we're going to do one more question. And this is from the free focus questions on their website. Right, so the data insights sample questions that anybody can take a look at. And this is a graphs problem. Right, a graphs meaning there's an image. It comes with two sentences, each of which has a blank in it, and those blanks have accompanying drop-down answer choices. We've got this Venn diagram that would certainly imply overlapping sets. right? It's already in an overlapping set. And you might be asking, like, well, why? Why would I want to look at this not as just the overlapping set they gave me? Right, so here's what they tell me. This pictograph is a survey of our students at this one school. And each one of these little symbols, as the chart says, represents 10 students for a total of 300. Again, I like to kind of just read everything, see what I've been given. I'm told in these two statements that if one student is selected at random, the chance that they'd be under 30 or a high school graduate. Notice that it says under 30 high school graduate. What do you notice about the Venn diagram that you've been given? The categories that you care about, under 30 and high school graduate, aren't the ones they selected for this graphic. It's the opposite. And so what I would suggest is that you take this information, right? They told you what a both is, and you build yourself a double set matrix first. So then you have all the subtotals and everything you need, which you can then just read off for the answers. So here are your answers. Let's take 2 minutes. All right, at about 2.5 minutes, you'll want to start guessing. Okay. So let's start by kind of identifying, like, you know what? Venn diagram might be really pretty visually, but it's not terribly useful when trying to do number crunching on any of this data. So I'm going to draw myself a double set matrix because that's just a way easier way to keep track of everything. And if I have to answer multiple questions about it, so much easier. So much easier. Okay, so what's something that we can be both 30 years of age and older and no high school diploma? I've also seen from my answer choices that there's, high school and, under 30. This is 30 plus, and this is no high school. So however you want to label it. And then my totals. Well, I know that the total is 300. And then I know that each symbol is 10 students. So in this center box, this would be 30 years of age and older with no high school diploma. That's 1, 2, 3, 4, 5, meaning 50 students go here. So this would be people who don't have a high school diploma, but are not 30 years of age and older. So that would be these people. So 4, that would be 40 for a total of 90, which should take me over here to 210. I know that 30 years of age or older plus high school is this group out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 is 110. And so high school under 30 would be these folks up here. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that's the 100 that would go here, which means under 30 would be 140. 30 or older would be 160. All right, so I've got every metric that I need just in case, right? I've got them all. And so I can now replace the graph completely with this double set matrix. I don't need this graphic up here anymore, nor do I need my little, pictograph business. So I can bring my little double set up here, and then I'll get our questions back. So according to the first question, if one student is selected at random, the chance that they'd be under 30, okay, so that's this row, high school graduate, or both. Okay, so for my yellow question, I want anybody who is under 30, a high school graduate, or both. So I'm just going to add up all these groups. So I know that this column is 210. So if I add this 210, right, or what I want is really like these three. In fact, I can kind of just do these guys right here. But so it's like these 3 boxes. I have my 210 plus 40 is 250. So this is going to be 250 out of 300, which is 25 out of 30, which is, if I divide both by 5, it's 5 out of 6. Boom. I'm all set. Yeah. Okay. If I then want to move to question number 2. So for question number 2, I'll do question number 2 in green. If one student is selected at random, the chance that student would be both under 30 and a high school graduate is just this box. So this box is 100 out of 300, or 1 out of 3. Much faster if we just go ahead and do the work, get it into a double set matrix, and now we can just count the numbers straight off the graph. Yeah. So I hope that you have a little bit better understanding of how to recognize this like paired on-off switch, right, this hybrid, and how to begin to set up our double set matrix, right? Our goal is to be able to recognize that it's overlapping sets. We'll then draw our 3 by 3. We label any both in the top corner. We add its opposites and totals and begin to plug the numbers in from the problem. Yeah. So hopefully you can go forth and find some more examples of how to use this and apply this on more and more practice questions. Please come hang out with us. We've got free prep hours throughout the month. We've also got them on our YouTube channel. If you're watching this recording, check out the whole free prep hours playlist. And we've got plenty of free study resources online. So check us out. You can attend any of our session ones for a full course for free by going to our manhattanprep.com/GMAT/classes/free. You can also check out our website for all sorts of other free stuff that we've got available. So please, please, please come hang out with us. Hopefully we'll see you around soon. See you at the next free prep hour. Thanks so much, y'all. Have a wonderful rest of your evening.